Sugar alters brain chemistry after only 12 days. Welcome to Health Info. We are on a mission to improving your health, one video at a time. Before we dive into the video, make sure to like, subscribe and hit the bell icon. Hear how sugar alters brain chemistry after only 12 days. New research in pigs finds that sugar intake alters the reward processing circuitry of the brain in a similar way to addictive drugs. Whenever we learn something new or experience something pleasurable, our brain's reward system becomes activated. With the help of natural brain chemicals, several brain areas communicate with each other to help us learn and repeat behaviors that improve our knowledge and well-being. Relying heavily on the neurotransmitter dopamine, the reward system helps explain several quintessential human experiences, such as falling in love, sexual pleasure, and enjoying time with friends. However, certain substances, such as drugs, hijack the brain's reward system, artificially activating it. Telling the brain to repeat pleasure-seeking behavior constantly is the mechanism behind addiction. But is sugar such a substance? And if so, does it help explain sugary food cravings? A United States scientist named Theron Randolph coined the term food addiction in the 1950s to describe the compulsive consumption of certain foods, such as milk, eggs, and potatoes. Since then, the studies exploring this concept have yielded mixed results, and some experts argue that speaking of food addiction is a bit of a stretch. New research helps shed some light on the matter, as Michael Winterdahl, associate professor at the Department of Clinical Medicine at Aarhus University in Denmark, and his colleagues examined the effect of sugar intake on the reward circuitry in the brains of pigs. Major changes after 12 days. The scientists analyzed the effects of sugar intake on 7 female Gooding minipigs, using complex PET imaging techniques with opioid receptor agonists and dopamine receptor antagonists to examine the animals' brain reward systems. The team gave the minipigs access to a sucrose solution for 1 hour on 12 consecutive days and then retook the scans 24 hours after the last sugar dose. In a subgroup of 5 minipigs, the team applied an additional PET scanning session after the first exposure to sugar. After just 12 days of sugar intake, we could see major changes in the brain's dopamine and opioid systems, reports Winterdahl. In fact, the opioid system, which is that part of the brain's chemistry that is associated with well-being and pleasure, was already activated after the very first intake, adds the study's lead author. Specifically, there were alterations in the striatum, nucleus accumbens, thalamus, amygdala, cingulate cortex, and prefrontal cortex after the sugar intake. Why sugar may be addictive after all? The findings, conclude the researchers, imply that foods high in sucrose influence brain reward circuitry in ways similar to those observed when addictive drugs are consumed. The lead researcher explains that the findings contradicted his initial expectations. There is no doubt that sugar has several physiological effects, and there are many reasons why it is not healthy. But I have been in doubt of the effects sugar has on our brain and behavior, and I had hoped to be able to kill a myth. He continues by emphasizing the addictive aspects of sugar intake. If sugar can change the brain's reward system after only 12 days, as we saw in the case of the pigs, you can imagine that natural stimuli, such as learning or social interaction, are pushed into the background and replaced by sugar and/or other artificial stimuli. We're all looking for the rush from dopamine, and if something gives us a better or bigger kick, then that's what we choose. Are pig models relevant? The researchers also explain their choice of minipigs as a model in which to study the effects of sugar on the brain. They say that previous studies have used rats, but even if these rodents do have a penchant for sugar, their homeostatic mechanisms, which help regulate weight gain and metabolism, differ significantly from those of humans. It would, of course, be ideal if the studies could be done in humans themselves, but humans are hard to control, and dopamine levels can be modulated by a number of different factors. They are influenced by what we eat, whether we play games on our phones, or if we enter a new romantic relationship in the middle of the trial, with potential for great variation in the data. The pig is a good alternative because its brain is more complex than a rodent and large enough for imaging deep brain structures using human brain scanners. If you liked the video, then give it a thumbs up and share it with your friends, and for more interesting videos, subscribe to the channel. Also, if you have any questions about this video, or health, or fitness, then leave a comment, and we'll get back to you. Until next time.